Boron is another example of an atom that does not obey the octet rule. And in this case, it's because boron only has a total of 3 valence electrons. The electron configuration is 1s2, 2s2, 2p1. That means that in the second energy level, there is a total of 3 valence electrons. It turns out that when we try to draw loose electron dot diagrams for boron, boron will never have more than 6 valence electrons around it. In fact, it will have exactly 6. On the periodic table, we see that boron is in group 3a. That means it has 3 valence electrons. Hydrogen is in group 1a, means it has 1 valence electron. Using the simplified periodic table, we see that boron's in column 3, which is group 3a on my simplified periodic table that I obtained by folding an actual periodic table. Take a look at the video that I've prepared for this if you need to see this for yourself. Hydrogen is in the first column. It has 1 valence electron. So boron, group 3a, it's in the third column of my simplified periodic table, 3 valence electrons. Hydrogen has 1 valence electron. If I'm going to draw a Lewis electron dot diagram for boron trifluoride, I have to do a tally of how many valence electrons are available. In this covalently bonded molecule, we have 1 boron. We have 3 hydrogen atoms. Each boron brings 3 valence electrons. Each hydrogen atom brings 1, but there's 3 of them. So to tally up the number of valence electrons available, boron brings 3, and each hydrogen brings 1, but there's 3 of them. That's a total of, well, 3 and 3 is 6. 6 valence electrons. All right, so let's start by drawing a structure. Put the boron down as the central atom, and I'll put the hydrogens around the boron. I'm not worrying about the molecular geometry in drawing my Lewis electron diagrams. That will be for a later lesson. Now I'm going to connect the borons to the hydrogens with a single line representing the sharing of a pair of electrons. To emphasize this, I'm going to put dots on each of the lines, 2 dots, each dot representing an electron. Okay, well, let's just take a look at this. Are the hydrogens satisfied? Well, yes, hydrogen obeys the, call it the duet rule. It only wants to have 2 valence electrons around it because hydrogen occupies a position in the first period or the first energy level of the periodic table, and it will be happy with the electron configuration of helium. It's happy with 2 valence electrons. So the hydrogens are all happy. What about the boron? Well, I said earlier the borons are actually happy with 6 valence electrons. So how many dots do we have down here? 2, 4, 6. Well, we got 6 valence electrons down there. We had 6 valence electrons to distribute. So this is a happy Lewis electron dot diagram.